Good afternoon, everyone. This webinar, Green Infrastructure and Urban Resilience, is the second in a series of 3 Together North Jersey Resilient Task Force webinars. It was developed by Rutgers University for the Together North Jersey Resilient Task Force. For more information on this webinar series and to register for webinar number 3, please visit the Together North Jersey website at togethernorthjersey.com. Before we begin, we have a few webinar instructions. First, please be sure to mute your phone as this webinar is being recorded and will be available at the Together North Jersey website at a later date. Please direct any questions to the bottom right chat box on your screen. We have reserved the last 10 minutes of this 1-hour webinar to answering any questions. Should we run out of time, please direct any remaining webinar questions to either myself, Stacy, or my colleague, Elliot, at the email addresses seen on the screen. The Resiliency webinar series, consisting of 3 webinars, of which today's is the second, is a product of the Together North Jersey Resilient Task Force. We would like to thank the following Resilient Task Force members for their guidance and assistance: Rob Freudenberg, Tim Van Epp, Kelly Flicka, Linda Weber, and Melissa Harkworth. The North Jersey Transportation Planning Authority, or NJTPA, is the federally funded, federally authorized metropolitan planning organization, or MPO, for the 13 counties in northern New Jersey. The federal government requires each urbanized region of the country to establish an MPO to provide local guidance over the use of federal transportation funds and ensure it is spent cost-effectively to improve mobility, support economic progress, and safeguard the environment. The NJTPA oversees more than $2 billion in transportation improvements each year. The NJTPA Board of Trustees includes representatives from each of the 13 counties as well as Newark and Jersey City. The board also includes a governor's representative, the commissioner of the New Jersey Department of Transportation, the executive director of New Jersey Transit, the chairman of the Port Authority of New York and New Jersey, and a citizen's representative. The Together North Jersey Resilient Vision is as follows. A resilient North Jersey is ready for adverse events: extreme weather, climate change, economic downturns, or other major setbacks, and can quickly bounce back from them. It protects wetlands and other crucial ecosystems and has strong, well-maintained infrastructure, transportation, utilities, water, sewer, etc. A resilient North Jersey takes steps to be prepared and reduce negative impacts on our communities. My name is Stacy Krause, and I will be the webinar speaker for today. I am a research associate at the Edward J. Blaustein School of Planning and Public Policy at Rutgers, the State University of New Jersey. This second webinar of the series will focus on the relationship between urban resiliency and green infrastructure with the following sections: climate change and precipitation, stormwater impacts on the urban landscape, green infrastructure project examples, municipal green infrastructure use, funding opportunities, the relation to the community rating system, and finally, the resources mentioned throughout this webinar are gathered and listed on a resources slide at the end of the presentation. According to NASA, the distribution of the world's rainfall is shifting as our climate changes. Wet areas may become wetter, drier areas drier, and storms more intense, leading to more chaotic weather around the world. The average precipitation in the country has increased since the beginning of the last century, with more winter and spring precipitation projected for the northern U.S. for this century. In the Northeast specifically, Heavy precipitation events have increased exponentially and are expected to continue. NASA lists regional effects in the Northeast to include heavy downpours, growing challenges on infrastructure and agriculture, and increasingly compromised fisheries and ecosystems. This map, taken from the National Climate Assessment, shows the Northeast experiencing a much higher percentage of heavy precipitation when compared to other regions of the country. In the following section, we will discuss stormwater impacts on the urban landscape. Stormwater runoff is generated from rain and snowmelt events. During these events, water flows over impervious surfaces instead of being absorbed into the ground. Impervious surfaces are mainly artificial structures, such as pavements, roads, sidewalks, driveways, and parking lots, as well as industrial areas such as airports, ports, and logistics and distribution centers, all of which use considerable paved areas that are covered by impenetrable materials such as asphalt. Impervious surfaces also include the rooftops of buildings and homes. During a rain event, rainwater generally either remains stagnant or travels down streets into the municipal storm drain system. With sudden heavy downfalls, storm drains can become overwhelmed and can lead to localized flooding. This graphic illustrates the impact of development on stormwater runoff. As the percentages of impervious surface increase due to increased land development, more stormwater runoff is generated due to less ground area for stormwater to infiltrate. Stormwater that does not infiltrate into the ground makes its way to local rivers and streams, impacting water quality due to the pollutants it picks up along the way. The literature suggests a link between impervious cover and stream ecosystem impairment, starting at just approximately 10% impervious cover. Stormwater runoff can negatively impact all areas, but particularly urban areas due to the higher levels of development and infrastructure present. Stormwater runoff causes flooding and pollution, which then causes property damage, health and economic impacts, which result from the flooding of homes, as well as infrastructure damage to roads, bridges, and rail. This infrastructure damage can lead to disruption in the public transportation system via delays and closures, and the need for costly fixes and upgrades, as well as water quality degradation, which can impact aquatic life and the operation of public beaches and parks. These are pictures taken from news reports a year ago in May 2017, showing the impacts of a flash flood event in Jersey City, the pictures on the left, and Hoboken, the pictures on the right. You can see storm drains overwhelmed, cars nearly floating down the street, and residents walking knee-deep in flood waters. So how do we address problems created by stormwater? One way is to integrate green infrastructure, commonly written and referred to as GI, into local development practices. Green infrastructure projects are intended to capture stormwater on-site, filter it through a natural system, and have the water absorbed into the ground instead of remaining on pavement where it can lead to flooding. Green infrastructure also promotes the capture of rainwater for reuse, such as irrigation. Examples of green infrastructure projects are listed on this graphic and include local collection systems such as rain barrels and absorption systems like bioswales and pervious pavements. When discussing stormwater management, we often refer to green and gray infrastructure. Generally, individuals are familiar with gray infrastructure, which consists of engineered drains, pipes, and walls. Green infrastructure, on the other hand, uses various kinds of vegetation and other natural processes to perform the functions of gray infrastructure. Local green infrastructure projects are generally spearheaded by planning, engineering, and public works departments and environmental commissions, with maintenance performed by the engineering and public works departments. Municipalities can also incorporate public input into green infrastructure on public projects. An example of this could be holding a public visioning session or accepting public comments on tree plantings along Main Street. In the next section of the webinar, we'll take a look at some green infrastructure project examples. Green streets include rain gardens and vegetated areas that collect and absorb runoff from the adjacent street, sidewalk, and parking lot areas. Since they are small in scale, they are ideal for dense urban areas where existing green space may be lacking and opportunities for new green space is limited. Benefits of green street design include stormwater management, but also aesthetic appeal that may make the area more inviting to pedestrians, which in a downtown area can mean more foot traffic and pedestrians lingering longer, potentially leading to economic development value for local businesses. Green street design can also contribute to traffic calming and improve pedestrian safety by causing vehicles to slow down. This is seen with the stormwater bump out in the top picture taken from the Hoboken Green Infrastructure Strategic Plan. Also, creating a buffer between cars and pedestrians reduces the pedestrian crossing distance on streets. Incorporating green infrastructure into streetscapes should include small street trees that do not obstruct streetlights and short vegetation that would not obstruct the open sight lines of motor vehicle traffic or pedestrians. On a county level, local green infrastructure can be promoted via policy. For example, the transportation element of the Passaic County Master Plan includes language supporting local green street demonstration projects. An example of this is the Halden Avenue Green Street Grant Award in Paterson, New Jersey, where over $300,000 in funding on green street principles is expected to treat nearly 8 million gallons of stormwater annually. Green alleys are alleyways that are repaved with permeable pavements and/or including vegetation that allows stormwater to infiltrate into the ground on site instead of ponding in the alley or moving onto the adjacent sidewalk area. Along with stormwater management, green alleys can also contribute to public safety by creating a more inviting space for residents or patrons and workers of local businesses. Green alleys can also lessen the prevalence of standing water and assist in managing vector-borne diseases. The City of Chicago Green Alleys program started as a pilot project in 2006 and had resulted in the installation of over 200 green alleys through 2010. Green alley techniques used in Chicago include proper grading to facilitate drainage, the use of dark sky-compliant light fixtures to reduce light pollution, and the use of recycled construction materials. The 2010 Green Alleys Handbook describes the approximately 1,900 miles of public alleyways as one of the most important and extensive pieces of infrastructure in the city, resulting in nearly 3,500 acres of paved impermeable surfaces. The program provided an opportunity for the city to better manage this resource while protecting the environment and assisting with localized flooding. Green roofs and walls are those that are carefully designed and covered with vegetation. It should be noted that in most cases, engineering work will need to be done to ensure that the building or structure can safely and adequately accommodate the weight and irrigation needs of the vegetation. The American Society of Landscape Architects has written design guides to assist in the materials and plantings to be used for proper water capture and energy impacts. Along with regulating the interior temperature of buildings, the American Society of Landscape Architects also estimates that a typical 2 to 3 story building could experience a 15 to 25% savings in summertime energy costs, and green walls can even reduce noise pollution by reducing the amount of sound reflected. In some places, green roofs are becoming opportunities for urban agriculture, which is a global and growing trend that can contribute to economic development, job creation, food security, and community building. The Brooklyn Garage rooftop in Queens, New York, a formerly contaminated site, is now a 43,000 square foot farm on top of a 6-story building that grows vegetation as part of a local CSA or community-supported agriculture program. The farm grows food, educates members of the public through workshops such as Intro to Green Roofs and Beekeeping 101, and facilitates events such as team retreats, weddings, and other private events. Pocket parks are small-scale parks that are ideal for urban areas where space is limited. Typically, the size of a pocket park is the equivalent of 3 lots, and it is recommended by the American Planning Association to be no bigger than 4 vacant lots. Where the need for outdoor space is greatest, local governments and nonprofit groups can acquire small vacant lots and land occupied by derelict buildings, usually at low cost. Along with the benefits of stormwater management, pocket parks are small and easily managed and maintained. They offer public health benefits with both passive and active recreation, so space and run to play, but also sit and relax in an otherwise bustling urban environment. Pocket parks can also address open space needs of municipalities where open space is extremely limited. In Boonton, New Jersey, Canute Park is a pocket park with the rear of the lot located along Route 287. The park is located between the high school and a residential area and offers a few amenities for local residents, such as a swing set and a picnic table. Community gardens and urban agriculture are areas of collective gardening on individual or shared plots on either public or private land. Gardens and urban agriculture increase public access to healthy food, which can be crucial in areas that may be considered food deserts where access is lacking. Community garden and agriculture programs offer an opportunity for food and nutrition education to local residents. They instill a sense of community ownership because the space is taken care of by the residents themselves, and the gardens also offer habitat for pollinators. An example of urban agriculture is seen with the Greater Newark Conservancy's Plotted Fresh program in Newark, New Jersey. Here, residents are offered plots for a small fee where they can grow healthy food. The plots are available for an annual fee of $9 for a 4-foot by 4-foot plot, or $15 for a 4-foot by 8-foot plot. Plotted Fresh also supplies startup materials such as seeds and technical gardening assistance for members. The program offers opportunities for education through a demonstration kitchen, nutrition programs, and field trips. The gardens are located at Hawthorne Avenue Farm, Smith Street Garden, and Sussex Avenue Garden. Increasing the presence of trees not only manages stormwater, but also aids in carbon sequestration, where carbon is captured and stored in plants and soil and reduces the urban heat island effect, which is an urban or metropolitan area that is significantly warmer due to heat stored in roads, buildings, and other structures. Cars and air conditioners also contribute to urban heat by converting energy into heat and releasing it into the air. Cities and towns can set tree canopy goals and work to increase the tree cover in their community. In forest ecology, tree canopy refers to mature tree crowns and is used to refer to the extent of the outer layer of leaves of an individual or group of trees. Jersey City, New Jersey performed a tree canopy assessment in which they quantified the existing tree canopy by city ward, listed the benefits and management challenges of city trees, and developed strategies for expanding the tree canopy to realize the full potential of urban shade trees, promoting long-term viability of the program, and creating a funding plan. The plan also laid out tree canopy goals in other urban areas in the Northeast, including Baltimore, Maryland, Boston, Massachusetts, New York City, Philadelphia, and Washington, D.C., who all generally aim to increase their tree canopy by 30 to 40% in the next 15 to 20 years. The inclusion of green infrastructure in the parking lot area design standards can include permeable surfaces for stormwater infiltration and the inclusion of vegetated landscaping along perimeters, in between parking spots, and along pedestrian walkways. Green design in parking areas enhances the pedestrian atmosphere and safety when vegetated barriers are created between walkways and cars. They can also reduce urban heat. An example of the inclusion of green infrastructure in parking design can be seen in the Cranberry, New Jersey Low Impact Development Ordinance that states parking lots with over 40 spots must provide pedestrian walkways using pervious paving materials and landscape dividers with curb flush curbing. Flush curbing is used so that rainwater can flow to and be infiltrated into the ground at adjacent vegetation instead of remaining on the parking lot and possibly causing flooding. Along with stormwater management benefits, green infrastructure can also be used to preserve community character. Beaufort, South Carolina, for example, has green infrastructure design specifications written into their local planning documents that are intended to maintain the character of the city. Historically, the landscape in Beaufort has included vegetated waterfronts that are easily accessed and inviting to pedestrians, which in this area includes both residents and tourists. Also common in the city are residential lots with ample trees and shrubs, often contributing to tree canopies over shaded streets and lush front yard gardens. Green infrastructure can also be an integral part of redevelopment projects. Along with stormwater management, redevelopment can offer opportunities for carbon sequestering and reduction of the urban heat island effect, as well as offer an aesthetic appeal that may have been lacking prior to redevelopment occurring. In a project done by the collaboration of Camden, the Camden Municipal Utilities Authority, Rutgers University, the New Jersey Department of Environmental Protection, the New Jersey Tree Foundation, and the Cooper's Ferry Partnership, a former contaminated gas station was transformed into a rain garden. The collaboration is part of the Camden, New Jersey SMART initiative, SMART being short for Stormwater Management and Resource Training. The initiative includes neighborhood green infrastructure projects, stormwater management policy development, and green infrastructure training programs. According to their website, to date, SMART has completed 50 green infrastructure projects, planted 1,500 plus trees, engaged over 4,000 Camden residents, created over 45 partnerships, captured over 62 million gallons of stormwater, and has invested $25 million in the city since 2011. In the next section of this presentation, we'll speak to challenges of implementing green infrastructure, offer more information on co-benefits beyond stormwater management, performance standards, costs, and how land use and zoning codes can be adjusted to better accommodate green infrastructure. There are a few challenges that municipalities may confront in implementing green infrastructure. First, municipal officials may not be fully articulating the benefits of green infrastructure beyond stormwater management to constituents. This can be a problem if there isn't sufficient public support for the capital spending related to a particular green infrastructure project. Local officials may be better able to sell constituents on green infrastructure projects if the multiple and multifaceted co-benefits are well known and understood by the public. Second, performance standards are not always known or easily understood by members of the public and sometimes municipal officials as well. We are generally comfortable with how storm drains and pipes work, and engineers are used to calculating the amount of stormwater that is carried by pipes of certain diameters, but less is known about the performance standards of green infrastructure. Third, green infrastructure may conflict with existing codes and/or land use regulation, making it necessary to obtain variances for green infrastructure-related projects on private property, which can be costly and time-consuming. Lastly, initial project as well as future maintenance costs may be unknown to local officials, and the cost-benefit of the green infrastructure projects unclear, causing the project design to either not be used or not used as frequently or to its full potential. This is part of a co-benefits chart taken from a training document by NOAA titled Green Infrastructure Practices and Benefits Matrix. In addition to stormwater management benefits, this chart also lists benefits related directly to climate mitigation, cultural benefits, and shoreline conservation for each green infrastructure practice listed along the left column of the chart. This chart could be useful in articulating the co-benefits to constituents for a public project, or offered as a resource to developers on how they can contribute to the community in the different areas of co-benefits. This is a graphic taken from Jersey City, New Jersey's tree canopy plan, which illustrates the many co-benefits for the public. Along with less flooding, there are a multitude of other benefits. First, on public safety. A study of New York City landscaping showed trees made people feel safer than building-related variables. In terms of public health, green open spaces reduce urban heat, create cleaner air, and encourage exercise and social interaction. Green infrastructure may also assist in mediating heat-related illnesses in vulnerable populations, such as the elderly and those suffering from asthma. With green infrastructure, there may also be implications for environmental justice. In less affluent areas, for example, there could be a benefit from green infrastructure when flooding and health-related issues are addressed, while creating green space in these areas where it may be lacking. Next, energy savings is seen in carbon sequestration, cooler building temperatures, and less stress on gray infrastructure. This can result in savings in utility costs and infrastructure upkeep and repair cost savings for municipalities. Lastly, green infrastructure, specifically trees and vegetation, is also said to increase property values and create a more aesthetically pleasing environment. It should be noted that there are those who will link this to an area's subsequent gentrification, so it is important to keep in mind that green infrastructure can be done on a site-specific scale, but projects may have community-wide implications. Some consider a renewal of an urban area as a good thing, but done incorrectly, it can have significant impacts. Here are a few points to keep in mind prior to undertaking an urban green infrastructure project. Gentrification occurs in older urban core neighborhoods when predominantly lower socioeconomic residents are replaced by higher income residents. Developing green space can lead to either real or speculative property value and/or the displacement of individuals to other low-income areas. Also, vegetation has the ability to both facilitate or mitigate crime, but is dependent upon the levels of concealment from the vegetative canopy and the frequency and level of maintenance of the area. While there is a general fluency with the performance standards of gray infrastructure in managing stormwater, less is commonly known about how much stormwater volume is captured by green or more natural structures. If this is a concern for a municipality, there are publicly available resources that lay out the performance measures and standards for various green infrastructure practices. These resources include a full database of summary reports gathered by the U.S. Environmental Protection Agency on how green infrastructure can reduce pollutant discharge to receiving waters, remove air pollutants, and reduce energy use. Another resource, titled Evaluating Green Infrastructure, a CSO control alternative for long-term control plans, is a report written by the New Jersey Department of Environmental Protection's Division of Water Quality. In Section 3 of this report is on green infrastructure implementation and performance monitoring, specifically determining rainfall depth and total runoff and peak flow calculations for CSOs, or combined sewer overflow communities. Another resource is a report written by the New York City Department of Environmental Protection on green infrastructure effectiveness. This report presents green infrastructure performance metrics created using the results of the modeling of various green infrastructure practices under certain scenarios. A last resource worth mentioning is the Green Infrastructure Database created by NOAA, the National Oceanic and Atmospheric Administration. This is a database of green infrastructure for coastal resilience and allows users to filter through the resources by coastal hazards, green infrastructure practice, and geography. This slide offers an example of a specific performance measure using the New Jersey Green Infrastructure Guidance Manual created by the Water Resources Program at Rutgers University. The manual details runoff captured with various green infrastructure practices. This table pulled from the report specifically references the stormwater volume captured by bioretention systems and rain gardens to both meet the state's water quality standard and a storm having the probability of occurring every 2 years. In terms of cost, one tool a municipality can use to guide decision-making is the Center for Neighborhood Technology's Green Values Calculator. The calculator compares the cost-benefit of various green versus gray infrastructure. It is a user-friendly, step-by-step process that assists users in choosing the infrastructure, either green or gray, based on average precipitation at a site, stormwater runoff volume reduction goal, defining the impervious areas of the site under the conventional development scheme, and culminates in the choosing from a range of green infrastructure best management practices to find the combination that best meets the runoff volume reduction goal in a cost-effective way. This is a screenshot from the Center for Neighborhood Technology's Stormwater Calculator and shows the different green infrastructure interventions you can choose from in the top left, the site statistics that would be entered by the user beneath that, and note that this is a small screen grab and there is more site information that can be added and varies depending upon the scenario that is selected, and then the results on the right, which shows the cost-benefit of the intervention strategy chosen via a percent reduction in stormwater discharge. Municipalities can adopt green infrastructure requirements for stormwater management that go above and beyond those required by the New Jersey Department of Environmental Protection. Most local codes dictate that sidewalks and parking areas must be constructed out of concrete, but allowing for and encouraging pervious materials would allow for stormwater infiltration. Also, while accommodating a certain traffic level and still allowing for emergency response vehicles, consider narrowing traffic lanes on neighborhood roads, which will create space for rain gardens and stormwater bump outs. Next, consider requiring dedicated open space with development that doesn't include existing right-of-way and utility easements or setbacks from lawns. Also, consider lower parking requirements for commercial and land uses, particularly in areas where there is public transit and/or bike and walking paths available, or where the operating hours of the buildings differ, creating opportunities for shared parking. With lower parking requirements, more space can be freed up for Green Street implementation. Next, review language in the local codes that defines parks based on size and uses, as this language may limit the incorporation of pocket parks and community gardens in certain communities. Lastly, most local code requires curbing be a certain height, generally 6 inches, sending water flowing down streets and into local collection systems. Allowing for and encouraging flush curbing would direct rainwater to infiltrate adjacent grass and vegetated areas, assisting with stormwater management. While state and county roads may have curb requirements that are not in the purview of local governments, flush curbing can be used on local streets, in residential areas, and on landscaped roundabouts and traffic circles. For additional guidance, Stay tuned for a model ordinance from Sustainable Jersey coming later this year. This new ordinance and model enhances on-site stormwater retention requirements beyond state regulations and is the culmination of 4 years of effort by dozens of organizations and agencies. The last section of this webinar will touch upon implementation opportunities, including costs and financing. To fund the planning and implementation of green infrastructure projects, municipalities generally look to use a few options. First, general city funds, which are funds collected from local taxes, fees such as monies developers may pay in lieu of implementing green infrastructure on their own projects, which then directs the money to the city to use for green infrastructure. The less popular stormwater utility, which generally assigns fees based on the impervious cover on the site. Credits and incentive programs, an example being a property tax break for a home or business implementing a green infrastructure technique that captures a certain amount of runoff. Public financing is another funding avenue for municipalities through bonds in which money is borrowed from a public entity and loans where money is borrowed from a private lending agency. And lastly, funding can be assessed through a public-private partnership, which would bring tax revenue and private investment to a project. An example of a public-private partnership is the Newark State Initiative, in which the 15 partners join together to fund and implement various green infrastructure projects in the city, including city street tree plantings and the implementation of over 71 green infrastructure projects at schools, parks, and residential areas. The various public and private partners in the initiative are listed on the slide. One project example from the Newark State Initiative is the Ujima Community Garden. This site is a community garden utilizing rainwater captured from cisterns on an adjacent rooftop, rain gardens at a nearby parking lot, along with tree plantings. The site uses recycled materials collected from nearby businesses, and local residents participated in the design and construction of the garden. This is a list of grant and loan programs available in New Jersey for green infrastructure projects, where more information can be found on specific program guidelines and available funds. This includes the New Jersey Water Bank, 319 grants, the Community Stewardship Incentive Program grant, Green Acres grants and loans, and the New Jersey Clean Communities grant. The New Jersey Water Bank, formerly the New Jersey Environmental Infrastructure Financing Program, offers low-cost financing specifically for green infrastructure projects in combined sewer overflow or CSO communities. There is no submission deadline, and applications are accepted on a rolling basis. Funds are available for governments, utility authorities, as well as public-private partnerships. The New Jersey Water Bank funds green infrastructure projects, including a wide range of green infrastructure techniques such as rain gardens, permeable pavement, and urban parks. In Hoboken, New Jersey, a $5.1 million loan was used to plan and construct the Southwest Park. Green infrastructure used at this park are designed to capture 200,000 gallons of stormwater. Techniques used can be seen on the image on the slide and included a vegetated bus stop shelter, a bioswale bump out, rain gardens, permeable paving, among other techniques. For municipalities participating in the Community Rating System, or CRS, which is a voluntary incentive program that gives points to communities who exceed the floodplain management minimums of the National Flood Insurance Program, or NFIP, points are available for activities such as open space preservation, the adoption of regulations that may include the requiring of green infrastructure for all development, and the development of plans that include green infrastructure practices. If the community participates and local officials implement these program actions, homeowners within the community who have National Flood Insurance Program policies may receive a certain percentage discount on their flood insurance premiums. That includes the content section of this presentation. Should anyone want to take a deeper dive into any of the content, this is a list of the resources referenced in the webinar. And as a reminder, these slides will be available on the Together North Jersey website at a later date. And with that, we'll take about 10 minutes to start reading through and addressing some of the comments and questions in the bottom right chat section of the screen. So I'll just go through them. The slides will be available as a PDF, and I believe the audio recording, the video recording, on the Together North Jersey website at togethernorthjersey.com at a later date. We may be able to email all the participants when this becomes available with the link. That's something we can certainly do. Is anyone aware of the typical costs to allow for the increased roof loads? So I'm not sure of the specifics of that, but the American Society of Landscape Architects does have a guidance document that lays that out in some detail, because I have heard in the past by certain engineers that communities and certain organizations will implement, these green roofs and these green walls without any consideration to the age of the building or the structural soundness there. So that's certainly something to look into. The materials used in the repaving of the Chicago alleyways is the idea that the materials be permeable. So I believe it was permeable asphalt. They do have a pretty comprehensive permeable asphalt, concrete, and pavers. So their website has a pretty comprehensive, pictures and summaries of some of those projects, and they also have their Green Alley Handbook on their website where you can look for further data. So community gardens, generally, who is responsible for the expenses of determining whether the soil on a proposed garden requires solution. Okay. Responsible for the expenses of determining whether the soil on a remediation. So that's a good question, because obviously I haven't come across any case studies where there was any contamination or remediation that would need to be done. I don't know how much a city would actually support something like that. So since these are generally either controlled by the local government or by community organizations, I'm guessing whomever owns the property would be responsible for that, but generally I would say it would be municipal leaders. A copy of the Cranberry Low Impact Parking Ordinance. So I did a quick Google search to find that. That may be something we can add to the resources section of the presentation. I wouldn't say it was a quick Google search. It did take a little bit of digging, sorry. And I'll certainly check for the year to see if there's been any newer iterations or updates to that. Is there any research on post-construction of green curb bump outs and the impacts of road salt from winter weather operations? So I have not seen any research on that, but that's actually a really good question and a good point, and perhaps there is some case study information out there. I'm guessing if there is, it would definitely have been done by you know, a Department of Transportation of some state or county who would generally be responsible for the upkeep of that area. Have electric vehicle car share been considered as part of the Green Complete Streets program? So I know that they are in some states. I believe California that is, but I definitely see that more so with New York's NYSERDA program. That's considered more in their energy program and doesn't link much to the Green and Complete Streets, but since it does focus more on the natural landscaping, but I definitely see the link there, and I think that there could definitely be a connection made. Great questions, great input. I think that along with the resources, if anybody wants, you know, a copy of these questions or any further input or has any further information or comments, please feel free to email us. So I'll give this a few more minutes in case anybody else has any questions. So again, this will be available on the Together North Jersey website. For specific project costs and timelines and things like that, I would definitely check out the actual links to the projects that are located in the resources section, along with the other grant opportunities. Linda Weber was kind enough to provide us with the information on the Sustainable Jersey Green Infrastructure Actions, along with the kind of stay tuned for the future Green Infrastructure Model Ordinance and guidance that they'll be coming out with. Okay, so we just got a question comment that said the New York City DEP is currently conducting a study on efficiency and effects of salt and other loadings on their 8,000 green infrastructure sites in Brooklyn and Queens. That should be out later this year, early next year. So that'll be a good resource to check out. It's funny reading all these materials and doing this research, that isn't even something that popped into my head, but now that I'm thinking about it, that's certainly something to take into consideration when implementing one of these projects is, you know, what would that impact be, and then who would be responsible for that, both in manpower and in cost. And maybe I'll try to find a site where that information either is now or will be updated in the future and add that to the resources list. Okay, so if there's no more questions or comments, we're going to end the presentation. I want to thank everybody for joining today. Please be sure to stay tuned at the Together North Jersey website for the presentation to be posted with the resources available, and also where you can register for webinar 3, which will be on the use of web-based resilience tools. So thanks everybody. Thanks for attending and have a nice day.